So we will continue with data types, correct? So in that, during this data types we have seen different types of data, but
Can't hear you properly, sir. Can you please?
no, I'm audible. Hello.
Yes, audible, but not clearly.
Okay, now that's the reason I told you that join me in that during
Now,
daytime, right?
now, okay.
So already completed. Now we are continuing with that data types, right? In the data types we have also completed more. Not in data type, we are continuation. Tell me. Operators, right? So in that operator we have completed unary operator. In that increment and decrement operator we have completed relational operator, we have created arithmetic operator, we have created and then we have completed which one, logical operator, logical and, logical or, logical not. Then we have completed which one, bitwise operator also we have completed. While learning bitwise operator only, when we started learning complement operator, at that point of time we during that point of time we got to know that what we have to do. We have to understand that complete how that complement operator is working. We must have to learn what complement, ones complement, two's complement. And before learning ones and two's complement at arithmetic level, before that we have to go with that which one, complete binary number system structure and their binary arithmetic. Not only binary arithmetic, we also have to go with that complement arithmetic also. Once complement arithmetic, two's complement arithmetic. Once we will finish all those, then learning this complement operator and their internal structure would be very easy for us to understand what is going on in at backend level, right? So during in the last session means previous, I have already explained you about this one, decimal and binary equivalent, how we are converting, what is the bit, how what is the bit, what is the size. Suppose we are having data type 1 byte, short, int, long, float, double, isn't it? For that their respective sizes there. For byte we are having 1 byte. 1 byte means what, 8 bit. And 8 bit means what, 8 bit means what, combination of 0 1 or only 0 or only ones, that is called 8 bit. 8 bit and 1 bit also. 1 bit means what, 1 bit means either 0 or 1, but bit value will be either 0 or 1, binary number only, that's it, only one, either 0 or 1. Suppose we are having only one coin is having two part. What is that two part? Head and tail. Coin is only one, having two part, head or tail, but at a time only one can come, either head or tail. So bit means one bucket. One bucket means what, that bucket value can have either 0 or 1, that's it, two possible value, that is binary numbers, right? And this is the bit equivalent for decimal: 0 1 2 3 4 5 6 7 8 9 10, then 11, then 12. In the last session I have explained you this from bit how to get this equivalent value. So conversion I have given over here, right? Then 1 star 8 plus 1 star 4 plus 0 star 2 plus 0 star 1 equal to 8 plus 4 plus 0 plus 0 equal to how much, 12. At the end we got final value as a 12 decimal, right? So it means what, the value which I have written over here, that is very equivalent to this one decimal, right? And conversion is this one, from binary to decimal, isn't it? From decimal to binary conversion also I have explained you in the earlier sessions, right? Now everything is okay over here. See, so this is this required only 4 bit. Without having 4 bit we can't represent. means at least 4 bit we require to represent value 12 in decimal, isn't it? If we will try to have that 3 bit and try to uh, like try to represent this 12 in decimal, can't possible 3 bits, right? Now in our system, in our programming system, what is the size, minimum size is what at byte data type, right? And byte is having 1 byte size, and 1 byte means what, 8 bit. Means what, if you will declare a variable type as a byte, and in that variable suppose you are having num, in that num you are trying to hold value 10. So 10 binary value is how much, 1010. This one only 4 bit is sufficient to hold or represent 10 decimal value. But in programming system we are having minimum size is how much, 1 byte, means 8 bit. It means what, in 8 bit will this 10 value, this 10 value will get represented 1010. How it will get represented 1010? So over here we are having value, suppose this is what byte means 1 byte, and 1 byte means 8 bit, right? Combination of this is, yes. Suppose you are having here 10, right? In this 10, before that you can add any value, will it affect to decimal value? No, right? There is no any effect, result is similar to 10 only, right? But in place of this, if you will try to add 0 next, this one, is there any value change? Yes, value got changed a lot, exponentially, right? So before digits say will add any, if will add any number of 0, it won't affect to their actual value, but it is up to that mathematical calculation. But in programming, mathematical scenario is something different, isn't it? Instead of in before 10, if you will add 0, what will happen, it will treat it as a octal number, not as a decimal number, right? And in decimal equivalent its value will be something different, right? We already know this, we have already done practice on this, right? Now here what is the scenario to discuss all these things, because we are having size at least 1 byte, right? 1 byte means what, data type size is byte only, right? So 1 byte means how much bit, 8 bit. 8 bit means what, at least we need 8 bit to represent any integer value. Any integer value means the value which are in the range. Byte value is having range or not? Yes, minus 128 to 127. If you will try to hold plus 128, it won't hold, right? So 8 bit minimum required, and we are having the value 10. So 10 representation in 8. How we are going to do that? For that 10, for decimal value 10 comma its binary equivalent in 8 bits. 8 bits. How we are going to represent? First we'll have to 10 means at least how much bit we required, 1010. This is in binary representation of 10, decimal 10. At least required 4 bit. 4 bit we are having, then 4 will also add 1 2 3 4, means total how much bit, 8 bit. So this is what, this is 8 bit. This is 8 bit representation of decimal 10. Clear? Now in programming we know what, we can have negative number as well as positive number, right? So how we can recognize, how we can like denote, or we can understand that this is the negative and this is the positive? Because ultimately at a hardware level, value is going to be represented in bit value only, right? Yes, in bit value only it is going to be represent, correct? So so for that, to to get to understand that whether it is value is negative or positive, we are having sign bit. Sign bit, it means what? That sign bit is going to represent whether this number is positive or negative, because number directly you won't be having that number either minus 10 or plus 10. No, you will be having that value at memory level in binary form, and that binary numbers only by looking you have to tell whether that number is negative or positive, because at the end on the hardware level that value will get stored in binary form itself, isn't it? So for that we are having this value, right? Sign aside. So value we are having which one? This one, correct. Now here MSB means most significant bit is what? 0. LSB, least significant bit, is what? 0. Now MSB, LSB both are 0 generally, but where is MSB and where is LSB? LSB means what? Least significant bit. This is left side. From left side very starting bit is called as what? LSB. MSB means what? Most significant bit. What where is that most significant bit? Very last bit is called as what? Most significant bit. But when it will get represented via data type size, either 1 byte, 2 byte, 4 byte or 8 byte. Getting my point or not? So this is over here, this is your MSB, this is your LSB, right? MSB where MSB bit represent sign bit, represent sign bit. Single MSB bit means only one bit which are most significant, only one bit which are least significant bit, only one bit. Getting my point? And one bit value we can have two, right? Either 0 or 1. So most significant bit is called, which one is most significant bit? And this one is most significant bit, only one bit, right? It's at this place it can have either 1 or 0, right? Yes. And this most significant bit is only responsible to indicate whether that this binary value is positive or negative. But how? Let me tell you. So this is called most significant bit, this least significant bit, where MSB represents sign bit, and sign bit value we can have 2, right? Only one bit, but its value can be 2, either 0 and 1, 0 and 1, right? Where sign bit, that is MSB, if it is 1, it means given binary value is what? Negative. That's it. Just opposite this one, if just opposite this one, if sign bit where sign bit, that is MSB, if it is 0, then it means given binary value is positive. Practically will show you, don't worry. I hope it is clear up to here, right? So at this is called as MSB, this is called as LSB, least significant bit. Most significant bit is the only bit which are responsible to represent sign. Sign means what? Either positive or negative, right? So when last or MSB bit is 0, it means what? Your overall the value of this in decimal equivalent is positive. That's it. If MSB is 1, it means your overall this binary value decimal equivalent is negative. Clear? Now next, moving further, in so positive representation and negative representation. We are having value 5, positive 5, negative 5. For positive 5, what is the bit minimum bit value? 3. This is going to represent 5, right? 1 0 1, this is 5. But 8 bit representation we are looking over here, we are working on 8 bit representation. So this 5 we have to represent in 8 bit. Getting my point? 8 bit means what? From here to here 8 bit. 3 bit is already available, now 5 bit we required, so 5 bit 0 0 0 0 added over here, right? And since it is plus 5 means positive, so directly I have added over here 0. That's it. It means what? This is representation of plus 5. Getting my point? Where MSB 0 represents positive number in simple form, no any complement form. Whether it is complement form or not, leave it. Simple form is only. This is what? Positive 5, no any complement form. Now the value same value, just only this bit you change their value, bit value. Now instead of 0 it is 1. Now this is representing minus 5. That's it. So if you have given 10, can you represent it its negative value in binary? Yes, you can represent. Leave about whether that is complement form or not. If you have given 10, any positive number, can you negate it? Yes. Just you write equivalent positive binary bit and very MSB bit value, you make it by a 1. That's it. That is going to represent your negative value. Getting my point? Now talking about complement form. What is complement? Complement symbol is this one. This is complement operator, right? Complement form means changing bit equivalent value, changing or toggle means toggling, TOGGLI, whether V4 form is there or not, you can check it. Toggling bit equivalent value, that is called as what? Complement form. That is also called as one's complement form. That is also called as one's complement form. Clear? Definition. Next definition, what we can say? One's complement means subtracting binary bit value from 1, subtracting each binary bit value from 1. That is called one's complement. Two's complement means one's complement plus 1. That's it. Not in every bit. Here this plus 1 we need to add in result of one's complement, not with each bit. I hope it is clear. One's complement, two's complement. Will give you ample number of examples. Just you follow me. So one's complement form, either one's complement or two's complement, are applicable. Remember one thing: one's complement or two's complement are applicable for both negative and positive numbers as well, right? Suppose you are having plus 5, so plus 5 representation in 8 bit, how much? This one. And you leave about this one, you leave about, suppose just you focus over here, plus 5 is there now. So plus 5 in 8 bit representation is what? This is called magnitude bit, and this is called sign also, sign and magnitude bit, sign bit and magnitude bit, right? Remember over here, here least significant bit and most significant bit, here sign bit, magnitude bit. Which one is sign bit? Sign bit is only 0, that is called MSB. When you leave this MSB, then remaining bit is called as what? Magnitude bit, which will give you that overall value. Getting my point? Now next thing. So one's complement you got over here, right? Definition. And two's complement also you got that definition, correct? Remember, complement is applicable on both positive as well as negative value, both, right? Now we are having one value 5, so plus 5 we already know how to represent, and minus 5 how to represent we already know, without any complement, right? But now we are going to work on complement, right? Without any complement, this is negative, this value is negative, and this is positive, this is negative, without any complement. But we are talking about complement form. Why we need to learn complement? Because Java programming language, at memory level, when that language will hold the value at memory level, always it uses two's complement form. Remember, that value in binary bit format will get stored on memory in two's complement binary form only. Remember, you can Google it everywhere. So we need, at memory level, if we want to understand working principle, we must have to be very much clear in complement form, binary bit as well as complement form. So this is without any complement, positive value, negative value, right? Now we talk about already one's complement. What is complement? One's complement, two's complement, right? And one's and two's, both complements are applicable on both value, either positive value or negative value. Remember, and we are having only two complement form: one's complement, two's complement. That's it. There is no any other complement. One's complement, two's complement. Now, what is the meaning of one's complement? Simply, from 1 you minus each individual binary bit of a decimal equivalent. That is called one's complement form. What is two's complement form? When you will add 1 in resultant one's complement form, then that is called as what? Two's complement. I hope it is clear. Suppose we are having this value plus 5, right? So plus 5 representation is how much? This one. Why it is plus 5? Because 8 bit we have used total, and when we look over here, MSB is 0. It means what? This is plus 5, 100%. Getting my point? Without any complement form. Now this is without any complement form. Without any complement form, right? Now we want to represent this plus 5 in one's complement form. How we are going to do to represent one's complement form? First, this plus 5 binary equivalent we have to generate, right? So plus 5 binary bit equivalent is this one, right? And this plus 5 one's complement form is what it is telling? From 1 we need to minus each individual bit, right? So just in one's complement form, just see, from 1, this is LSB 1, this 1 you need to minus from 1, you imagine that 1 is there, so from 1 1 1 1 1 only you are going to minus 1, how much you will have? This 0. Clear? Now this is second bit 0, so this 0 you need to subtract from where? 1. Where is 1? Just you imagine that 1 is there, so from that 1 you are going to minus 0. 1 minus 0 how much? 1 only. So your second bit is over here, resultant 1. Now third bit you are having 1, right? So this 1 you need to minus from 1. Why? Because we are calculating 1's complement, so from 1 we need to minus each bit. So this is 1 over here, we will minus from 1. 1 minus 1 how much? 0. Third bit is 0. Remaining all are 0 0 0. So from 1 you will minus 0 0 0, how much you will have? This 1 1 1. Now this complement form is also applicable on sign bit also, so 0 to 1 or 1 to 0. Now you just tell me, only look over here, this is the ones complement of plus 5, right? Once you will look at the MSB of ones complement, you are getting over here what? Plus 1, means only 1, and 1, if MSB is 1, that MSB is also called as what? Sign B. If MSB is 1, it means what? The ones complement which you have calculated, that it is what? In negative form, sign bit. So plus 5 in ones complement became what? Minus 5. Now minus 5 and their bit value is which one? This one, but it is not a simple binary form, it is in ones complement form. Are you getting my point? Are you getting my point? Correct. Now next. So your assignment over here, once again, assignment. Calculate one's complement of the following given below. A, how much? 7. B, 17. C, 11. D, 33. This is your assignment. Only one's complement you have to create, and these are all what? Positive only. Always remember, either you create, whenever you require to generate one's complement form, first you have to create bit of positive value plus 5. Even I would give you over here, see that 5e minus 5 even will give you minus 5. First what you need to consider, you need to create its positive value, and then positive value, negative value you will have to create. Suppose over here we are having minus 5, right? Minus 5, how we are going to represent minus 5? Minus 5, so minus 5 you are going to represent, take one's complement, flip flop. So minus 5, this is 1 1 1 1, this is one's complement, right? In minus 5 how you are going to represent this? Simply you need to take 5 equivalent 101, and then over here 3 4 5 6 7 8. This is 5 and this is what? Minus 5 1 1 1 1 4 1, then 0 1 0. This is what? Your minus 5, right? It is in ones complement. This is your -5, right? So up to now just you work on these positive numbers and try to calculate its ones complement using 8 bit. Meet me tomorrow in daytime. I will explain you complete whole, because at daytime I will be having the time. Thanks, then you can leave for the day. I'm sharing this one to you.
Okay, sir. Thank you.